Hi guys. Hey, it's good to see you again. It's Miss Murphy. Today we are going to discuss significant figures. All right. So you may be thinking, what are significant figures? Well, let me just tell you, you're not going to enjoy them, but I'm a significant figure type person and it's just proper. Okay. So the first thing to do is to talk about what do we even mean? So think about it. I think I'm going to change my camera. Let's think about it like this. So you are making some measurements. Oh, it's my whiteboard. Let's get it right. Like have it straight. But you're making some measurements. And you measure that the length is 4 centimeters. Your friend measures the width of whatever this object is, I don't know, to be 3.2 centimeters. And, oh, it looks like I'm gonna have to go get my handy dandy calculator, which I don't have right next to me. And the height here, let's say, I didn't go anywhere, I'm right here. Right here. Right here. Okay. Let's say that the height is 7.45 centimeters, right? And if we wanted to use these measured values, right? All of these values are measured. We know that because look, they have units of measurement behind them. And get the area, well, we would do the length times the width times the height, right? And we have those values right here. So I would do 4, oops, let's turn it on. 4 times 3.2 times 7.45 equals. And that would give me 95.36. Okay? All right. Well, you're probably, oh, we need to have a unit of measurement behind that. That's a centimeter times a centimeter times a centimeter. So that will be a centimeter cubed. Okay. Now, here's the point, right? What's the point? The point is I've used 3 measured values to obtain another measured value, right? The area. And this cannot be more precise than the measurement that was the least precise, right? We could see that this is the least precise measurement. We could see that this is the most precise measurement because this stops at the ones place and this goes to the hundredths place, okay? Because whoever took this measurement, shame on you, had a very poor piece of equipment, which, no, this is not a good measurement at all. Or they obviously did not guesstimate the next value, right? You're supposed to guesstimate the next value. And in doing that, you invite some error. This is true, another reason we have significant figures. But whoever took this measurement really limited our precision by not guesstimating that next value. So if this answer can't pretend to know these place values, because they weren't recorded, okay? So we're gonna see that occur here, and it's going to help us to round our answers. So what these Sig Fig are going to do is gonna allow us ultimately to learn to how should we present our final answer? How many numbers should be here? How many numbers should be after my decimal? All right, so that's what we're getting to, but it's going to take a couple small lessons to get there. So that was just a little bit of insight as to why we have Sig Figs. Our final answer cannot be more precise than our least precise measurement. Okay, if you understand that, that's great. So what I'm going to go through, and your goal right now is to learn how to determine what values are significant in a recorded measurement, okay? And that is learned by learning and applying the significant figure rules. Now, the first thing I'm going to say, so that I don't forget, is that this relates to measurements. All right? That means not all numbers are measurements, right? Counting numbers, if I'm counting items, I'm not measuring them. I'm counting how many there are. So this is not a measurement, okay? Not, you can't see that. Not measurements. Conversion factors, all right? Conversion factors. You might be saying, what is a conversion factor? Well, conversion factor is similar to saying that 1 liter is equivalent to 1,000 milliliters. Okay, that is a conversion factor. Or 1 foot equals 12 inches. All right, this is a conversion factor. It allows me to convert between units. Okay, now counting numbers like 2 people, right? 5 days. These are numbers that are counting. These are not measurements, and they therefore do not pertain to the significant figure rules. And we could even say that they have an infinite numbers of sig figs, okay? Infinite number of sig figs. What that means is that when we go to rounding our answers appropriately at the end of a problem, we don't need to worry about the numbers like this. They will not affect how we determine what our answer should look like, okay? I'm gonna erase this now, okay? So when we talk about the Sig Fig rules, conversion factors do not apply, and counting numbers do not apply, all right? Okay, so that's what I mean by it relates to measurements. Those values are not measurements. All right, so what are the rules? Well, all non-zero digits are significant, okay? That means if in your measured value, the number is not a 0, then that number is significant. So 127 meters, how many, it's a measurement, it's a unit. This is my unit of measurement. This is measuring a distance. How many significant figures? Yes, that's significant because it's not a 0. Yes, and yes. I have 3 sig figs, right? It doesn't, I could move the decimal. I could say that I have 1.27 meters. How many significant figures? Well, all of these are significant because they are not zeros. So that's going to give you 3 sig figs. Okay. All right. I'm just going to go like this and go like this and go. Hey, just want to keep you with me. Okay. You're still with me? We got 3 more rules to go through. All right. 3 more rules. So you're still with me. All right. Let's go back there. Ugh, I hate it when it does that. The camera stops on me. Okay. So first rule, if it's not a 0, it's significant. Second rule, that would be rule 1. Rule 2, I may find myself running out of room here, is that, okay, so that just kind of leads to the question like, well, what about zeros, right? Well, zeros can come in 3 places. They can come at the beginning of numbers, they can come in the middle of numbers, or your zeros can come at the end of numbers. So let's first talk about our sandwich zeros. Zeros in between numbers. Okay, those are going to be our sandwich zeros. they're the easiest. They are always significant. Always significant. Always. There's no ifs, ands, or buts about it. So if I have a value that says 25,002, it needs to be a unit of measurement, right? It needs to be measuring something. Let's say, I don't know, hertz. Hertz, it's frequency, hertz. But my big point is, well, how many significant figures are in this measurement? Well, this is a non-zero digit, it's significant. This is a non-zero digit, it's significant. This is a non-zero digit, it's significant. I can look at this in two ways. Anytime I have zeros that fall within numbers, zeros between numbers, they're always significant, right? And the other way I can look at this is I'm never going to have this number be significant and this number be significant. And then everything in between is going to be significant. It'll never be a yes, no, yes. If this is significant and this is significant, then everything in between is significant. Remember, this is the number we want to know which one was guesstimated. So therefore, this is significant. And this is significant. Zeros in between numbers, always significant. And we have 5 significant figures. All right. So notice, my only other 2 rules are going to talk about the zeros when they're up here and the zeros when they're back here. And then we will be done. So I'm going to have to erase this because my board, let's see if I can fit it in. See if we can fit in number 3 and 4. Okay, leading zeros, right? That makes sense. What are leading zeros? Those are zeros that come in the beginning, right? Leading zeros. Well, they are never. So what we just learned was that if they're in the middle, they are always significant, right? But if the zeros are in the beginning, then they are never significant. So we have an always situation and we have a never situation. All right. These zeros function as placeholders. Zeros that are leading function as placeholders. Okay, they function as placeholders. So I'm going to give an example. Obviously, I'm going to start my number off with zeros, right? I'll keep it simple, 0.010. Oh, no, yep, 0.5. And we'll make that meters, okay? Question is, how many significant figures are in this measurement? Well, these are my leading zeros. Remember, it's always about the zeros. These are leading. So they are not significant. Let's put those X's up top so we have room for our 4th rule and last rule. They are not significant. This is a number. It's not a 0, so it's definitely significant. Here's a number that's not 0, so it's definitely significant. And here's a 0 that's in between numbers, so it's significant. And if this is and this is, then this is as well. So we've got 3 sig figs in this measurement, okay? The last rule is rule number 4. All right, we've got rule number 4. And what we're going to do here is we're going to talk not about zeros that come in the middle of values, not about zeros that come in the beginning of measured values, but as you could guess, about zeros that come at the end. So we will call those trailing zeros. And that's for zeros at the end of numbers. All right. Well, we've got an always situation when they're in the middle. We've got a never situation where at the beginning. So we are now going to have a maybe. It's not an always, it's not a never, it is a maybe situation. when they're at the end. All right. There's an easy way to figure it out. They may be placeholders. If they are placeholders, they are not significant. All right. I'm just going to say that because it might help someone. Okay. I have an easy way to look at these though. These are the ones that cause students the most confusion. Students, Sig Figs it'll take you a minute to get it. All right. So you're going to have to practice this. You're going to have to. So trailing zeros, maybe. So let's write a number that, let's see, we'll start with a 5. We'll write a 4. I guess I should give you the rule, shouldn't I? I'm sorry, I'm going to have to erase that. I need to give you the rule. So they are significant. So the answer is yes, those zeros are significant when they're at the end of numbers if both a number and a decimal is anywhere in front of them. Right? We will see through an example that the trailing zeros, we are almost finished, are significant if both a number and a decimal is anywhere in front of the 0. I'm going to write that 0. You can kind of just put it at the end and parenthesis in whatever those things are. Parentheses? Yeah. Okay, so I'm going to have to give you an example of that. I'm going to go ahead and erase this board. We'll look at a few more. Okay. Okay, so this will be our trailing zeros, right? I should at least start at the top, shouldn't I, guys? Trailing zeros. Once again, those are zeros that come at the end of numbers. Oops. Get myself worked out here. This is zeros. So let's do 2, 5, 0. Okay. Let's do that. That'll be 250 milliliters. That's a common value. 250 milliliters. Let's look at this. This is a 2, so it's significant because it's not a 0. This is a 5, so it's significant because it's not a 0. Oh, no, I have my 0. Remember, those are my question marks. Well, is there both, look at the rule, a number and a decimal in front? Is there both? Right? Well, we need a number and a decimal. Well, this 0 has a couple numbers in front of it. This anywhere up here, but yeah, there's a number. By number, I mean non-zero digit, right? It's got to be a non-zero digit. Anything between 1 and 9. Is there a decimal in front of it? No, there's not. There's not a decimal in front. So this 0 is not significant, right? It's got to be both. This is not significant. It is a placeholder. It is making my value 250 as opposed to 25, right? It's not 25 milliliters, it's 250 milliliters, but it's a value that only has 2 sig figs, right? It's not 251 milliliters. It's not 255 milliliters. Right? This would have 3 sig figs. They're all non-zeros. This would have 3 sig figs. This one doesn't know what this place is. It's about 250 milliliters, right? So this value only has 2 sig figs, okay? Let's look at that again. Let us look at another one. let's say that we have 4,000, all right? Milliliters. Milliliters are common. Well, how many sig figs are in this measurement that you wrote down? Doesn't look good to me. 1 is never good. This is significant because it's not a 0. These are trailing zeros, right? They're trailing. Remember, if they're trailing, we must see both a number and a decimal in front. Once again, we see the number. We don't see the decimal anywhere. There's no decimal anywhere. We'll look at another example in a minute. So this measured value has 1 sig fig. That's horrible. I mean, you should never record them and write it down as 4,000 milliliters. You just took a measurement that has 1 sig fig. I want you to remember that if we ever make it to the lab, okay? Let's look at another one. Let's do 4,001.0 milliliters. Now this is a different story. This looks good. Is this significant? Yeah, it's not a number. Oh, look, here's another number. It's significant. Therefore, the zeros in between are definitely significant, right? And here's another trailing 0. Trailing 0, right? So if there's both a number and a decimal anywhere in front of it, then it's significant. Well, this time we do have a decimal in front of it, right? This right here looks like a decimal to me. So that's check. And over here, what I see are a couple. Remember, the number has to be non-zero. Well, I see a couple of those. So this is checked. We got both things. He's in. We now have a measurement that has 1, 2, 3, 4, 5 significant figures. That is excellent. You want to have the most sig figs, right? The more sig figs, the greater precision, the more precise that measurement is, okay? All right? Precision can be used in a couple different ways. I understand that if you were thinking back to our previous definition. It's all about the zeros, guys. Students get confused with zeros. 0.000200. I don't know, liters. Well, these are in the beginning, so they are not significant. They are placeholders. This is a number, so it's significant. These are trailing zeros. Yes, there's a number in front of it right here. And yes, there's a decimal. It's right here. So they are significant. And we have 3 sig figs. All right. I've got to say one more thing, because there is an exception, right? One more thing, guys. This is it. 2,000 milliliters. Okay. Let's look at our sig figs. Yes, it's not a 0. Here's 3 zeros that are trailing. Remember, if they're trailing, there has to be both a decimal and a number, right, in front of it. Doesn't matter what order, doesn't matter. There's the number. There's no decimal in front of these zeros, so they are not significant. Okay, so you should be saying, all right, that's 1 sig fig. Miss Murphy said that's not good. We should always have more than 1 sig fig. Sometimes you'll have word problems. They could be 1 sig fig. Don't worry about it, but you'll learn to get frustrated by it. Okay, now listen to my words. If, for some reason, which you will later understand, I want these to be significant, I want to say this is exactly 2,000 milliliters, then what I'm going to do is I'm going to put a decimal right here. I've gone from a number that at 2,000 milliliters had 1 sig fig, right? We just talked about it. To a number that is 2,000 decimal point milliliters. Well, that decimal point is magic. It is telling you, it is communicating to you that whoever put it there, these are here with significance. They are measured to be 0, 0, 0. They're not just there to make the number big. They are there to make the number big. They are measured to be zeros, okay? So I now have 4 sig figs. This is much better than this. What determines your sig figs when you're making a measurement is, that's why we make correct measurements. That's why we guesstimate that last value, is to keep as many significant figures as we can. If you remember that lesson, and I hope you do. Remember, we always measure to what we know, and then we guess that next value. It was a video lesson called Making Correct Measurements. That's allowing us to keep as many significant figures as we can. The more, the better. Okay, so that, guys, is that is how to count significant figures, right? How to look at a value and determine how many of those values, really what I should have said was how to look at a measurement and determine how many of those values are significant. Remember that if it's a counting number or a conversion factor, we would say that it has an infinite number of significant figures. It's not really measured with any error. There's no error involved in that, okay? If it's a number, it's significant. If it's 0, it can come in 3 places. It can come in the beginning, never significant. In the middle, always significant. At the end, maybe. We know that it will be if there's both a decimal anywhere in front of the value, the 0, and a number anywhere in front of the 0. Both of those are in front, we're good. We also learned the magic trick, right? The decimal magic trick, when you just put it at the end and it makes those zeros in front of it significant, okay? So I'm gonna sign off now, and I'll be looking forward to seeing you later, okay? See ya, bye.